Now we will look at another model, which is Rutherford's model. So he actually gave the scientific model. His experiment was scientifically proved. So according to Rutherford, he actually discovered the nucleus. He gave the idea that the electron move in spiral motion. Like, for example, I'm having an electron over here and it will move, and eventually it will lose its energy and fall into the nucleus. He gave the idea of nucleus. He said that the electron moves in spiral motion and eventually it will lose its energy and it will fall in the nucleus, which is obviously not true, and there are many, like 2 to 3 drawbacks of Rutherford too. Now we will talk about another model, which is Bohr's model. He said that the electron actually moves. He gave the idea of orbit first of all, and he said the electron move in circular motion. For example, I'm having an electron and it will move like this in a circular motion. This is nucleus, so it will move like this. It will move in a circular motion, and he said that the electron move in orbit. Okay, let me clear one concept. These orbit are now S, P, D, F. In S, only 2 electrons can be fit. In P, we have 6 to 10, 14. So according to them, we will having now subshells. So these are actually subshells. We are having K, L, M, N. So now the atomic model of Bohr was challenged by Heisenberg. As we have learned now that what Bohr said, he said that the electron move in circular motion and he gave the idea of orbit. So Heisenberg challenged him. He actually he wanted to observe the electron. What he did an experiment in which he wanted to observe the motion of electron. He wanted to see the motion of electron, that is it circular, is it what. So what did he did? Heisenberg. So what he did, for example, this is an atom. Okay. Okay, when he tried to see the electronic motion with the light with low wavelength, so he couldn't observe electron. As we know that electron is quite minor, we know the mass, we know the charge, so obviously it's quite minor, it's very small, so we can't see this with very small wavelength, so he couldn't observe. So when he observed that with high wavelength, so as we know that whenever electron gets energy, it get excited. Okay, whenever we give energy to an atom, it get excited. Whenever it absorbs energy, so it get excited, and whenever it emits energy, it get de-excited. Which means when we will give it energy, it will jump to another shell, to the upper one shell, and when we will don't give this energy, so obviously it will return to its original shell. So now when he gave the high wavelength to the electron, he obviously the electron jumped off to another shell, so he couldn't observe. So he challenged Bohr that I couldn't see electron. How did you saw? I have done with my experiment. Where is electron? I couldn't even see electron. I couldn't see the circular motion. I want to see where is this. So this is how he challenged Bohr.